Dear friends, now we have already studied this parabola. If this is an axis and if we rotate the generator, now if there is an angle alpha which makes, if the generator makes an angle alpha with the axis, if this is an axis and a generator, if it makes an angle alpha, and if we rotate this generator around the axis, then we get a figure something like this. Please note, since these are lines, we will get in this direction infinity. So we will get two naps. This is one nap, this is another nap, this is vertex. Now please note, the angle made by axis with the generator is alpha, and if we cut this by making an alpha, please note this goes up to infinity. So if we cut this with alpha equals to beta, that is axis of cutting is beta, then we will get this as something like this. Please try to understand the curve. We will get the curve which will cut this nape in this way. That is, we will get a curve which is called as parabola. Here please note, alpha is equal to beta. Alpha is the angle made by generator with the vertex, and beta is the angle made by the cut with the axis. Let us try to understand this parabola in more detail. Now, what is parabola? So if you draw a line and a point, set of all the points which are equidistant from the point and the line. Please note, if we take equal distance from the line and point, so I will get some point somewhere here. Now if I go on plotting from this line and this point, I will get a point somewhere equidistant, so I will get somewhere here, which is equal, this distance is equal to this. If I take some other point, I will get somewhere here, this distance is equal. If I take third point, I may get something somewhere here. If I take the fourth point, I may get, please note, this is perpendicular, so I will get this distance is equal to this distance. This distance is equal to this distance. Now if you join these all points, then I will get a curve in this way. Please note. So set of all the points which are equidistant from a certain point and a certain line is called as parabola. This line is parabola. This curve is parabola. Please note, these are all the points which are equidistant from the point as well as line. This line which we are talking about, this line is called as directrix, and the point is called as focus. And the line which is passing through the focus and perpendicular to the directrix, please try to understand, line which is perpendicular to the directrix and passing through the focus is called as axis. So this line is axis which is passing through the focus and perpendicular to the directrix is called as axis. The line which we are considering for drawing the parabola is called as directrix, and focus is the point from which all the points on parabola are equidistant from the directrix. Please note, when we talk about a distance of a point from a line, when we are talking about a distance of a point from a line, we always draw the perpendicular. This perpendicular is only called as a distance. So if this is the point and this is the line L and point P, then when we talk about distance of a point from a line, we always draw the perpendicular. So when I am talking about a point on the line and a line, I am always drawing perpendicular on the line. So this point is equidistant, and when I am taking a point, so I am considering the distance between the 2 points. Here, when I am considering the point and the line, I am always drawing a perpendicular on the line. So please note this distance. If we go on joining all the points, we get a parabola. And one more point is left. The axis and the parabola. The axis and parabola intersect at a point, and this point is called as vertex. Please note, intersection of a parabola with the axis is called as vertex, and the line which is passing through the focus and the vertex perpendicular to the directrix is called as axis. Now it can be defined in other way also. The line passing through the vertex and perpendicular to the directrix is called axis. Line passing through the focus and perpendicular to the directrix is called axis, or the line passing through the focus and vertex is called as axis. So it can be defined in many different ways. So let us try to understand the parabola in simplest form. Now if you try to draw a parabola equation in a simplest form, then this vertex lies at the origin. If vertex is at origin, then we get the simplest form of parabolas, simplest form of equation of parabolas. Here vertex is at origin of x-axis and y-axis. So if vertex is here, then we will get a parabola symmetric to symmetric about x-axis, either like this, or we may get symmetric on like this x-axis. Again it may get symmetric to y-axis, or we may get symmetric to. So these are the four parabolas which have the simplest form of equations. So we are going to consider the simplest form of equation. This is one of the parabola. This is the other form of parabola which is symmetric to x-axis. Then if you consider y-axis, then we will get this parabola as the simplest, and another will be. So there are four equations of parabolas which can be written in simplest form. Let us try to understand this. Now if this is vertex and focus will definitely lie on axis. Please note, in this case axis of a parabola is x-axis. In this case also axis of parabola is x-axis. Here please note, focus will lie on x-axis. In this case also focus will lie on x-axis. So if focus lies on x-axis, and if we name this point as, please note, it is lying on x-axis. So let us name this as x coordinate as a, y coordinate will be definitely 0. If we name this equation, if we name the focus as a0, then directrix will definitely pass through minus a0. Please note, this point will be minus a0, since we have already defined that this point on parabolas are equidistant from the directrix and the focus. So this vertex is also equidistant from focus as well as the point on the directrix. So this point will be minus a0 if the focus is a0. Now if the equation of this equation, if the line is passing through minus a0, we know equation of line parallel to y-axis is x equal to constant. So equation of directrix will be x equal to minus a. Please note, x equal to minus a is the equation of directrix. Vertex is at origin, and a0 is the focus. Minus a0 is the point where directrix intersects with the axis. In this case vertex is at origin, focus is at a0, and equation of directrix is x equal to minus a. Now if you take another form of the simplest form of parabola, then this point, let us name this point as minus a0. Dear friends, we have taken focus as minus a0, origin at vertex at origin. So this is the vertex which is at origin. This is focus which is at minus a0. Since the point lies on x-axis, its y coordinate will be definitely 0. And since it is this side, that is negative direction of x-axis, we have taken the point as negative. Now please note, we know the equation of directrix. Directrix always is equidistant from, or all the points on parabola are equidistant from line, that is from directrix as well as the focus. So if this distance is minus a, please note, if this is negative a, this distance will be positive a. So the point of intersection of axis with the directrix is a0. Now if the directrix is parallel to y-axis, it means its equation will be x equal to constant, and if the line passes through a0, it means equation of this directrix will be x equal to a. So equation of directrix is x equal to a, focus is at minus a0 and vertex is at origin. And please note here axis of parabola is x-axis itself. Now if the axis of parabola is y-axis, axis of parabola is y-axis. Then also we do have two conditions, that is a parabola which opens upward and a parabola which opens downward. In this case, the focus will lie on positive direction of y-axis. So let us name that point as A0A. Please note here, since it lies on y-axis, x coordinate will be 0 and y coordinate will be positive because it is lying on the positive direction of y-axis. Now if the focus is 0A and vertex is at origin, we have defined that all the points on parabola are equidistant from the focus and the directrix. So directrix is a line which is parallel to x-axis in this case. So if it is parallel to x-axis, it will be something like this. And since this distance is a, this distance will also be a, and it is in the negative direction of y-axis. So it will be this point of intersection of axis of the parabola and directrix. The point of intersection will be 0 minus a. Please note, if this line is parallel to x-axis, then the equation of line will be y equal to constant. Since it is parallel to x-axis, equation will be y equal to constant. So here you will notice that equation of line is y equal to minus a. So it will pass, since it is passing through minus a, you will see the equation will be y equal to minus a. Please note, focus is 0a, vertex is at 0, 0, and equation of directrix is y equal to minus a. Now we have the next type of parabola, that is opening downward, that is in the negative direction of y-axis. So please note here vertex is at origin. We are considering the simplest form of the parabolas. So in all these conditions we are considering that vertex is at the origin. So here we have the fourth condition where vertex is at origin and it is opening downside. Please note, axis of parabola is y-axis itself. So axis of parabola is y-axis itself. It means focus will lie on y-axis. So the point of focus can be 0a. So I have taken 0a as the point. It means if it is 0a, then the another line which is we have defined that all the points on the parabola are equidistant from the focus and the directrix. So if this distance is a, then this distance will also be a. Please note here, since it is negative, we are taking this y coordinate as negative. So focus is at 0 minus a, and equation of line since parallel to x-axis, it is y equal to constant, and if it is y equal to constant, then it will be y equals to a, and the point of intersection of the axis with the directrix is 0 a. This point is 0a, vertex is at 0, 0, focus is at 0 minus a, and now we will find the equations of parabolas in all these four cases.